Yeah, I look more like the picture, right? More or less. Right? Okay, let me put it like this. Then about my talk, it's about fleet management. And I think that this is a subject that is going to be booming in the next years, because you know that we are having the intention to have automated warehouses, hospitals, hotels, restaurants. For all those cases, fleet management is going to be a key subject. At present, there are some proprietary solutions that work, they are good, but here I'm going to talk about open source solutions for that. But first, let me tell you what is the fleet management problem, right? So in a fleet management problem, what we have is a set of robots that they are each one doing a different task or similar task also, they could be. So they are all coordinating between themselves in order to manage the whole system. It could be running a hospital or running a restaurant, delivering, taking care of the orders, cleaning, all those things, different robots in the same environment. And they have to coordinate between them. So that's a problem that we try to solve with fleet management software. Then, when we try to implement this system of several robots working together, each one doing a task, we have a problem of integrating those robots. Each one can do a different thing and has different abilities. Like here, the mobile base, the robot arm, the drone, whatever the robot. We also have the problem of buying those robots from different manufacturers. For example, in this slide, you can see the same robot functionality from a functionality point of view, but that is made by different manufacturers. So I don't want to be tied to a specific manufacturer. I want to buy one robot from this one, and then 2 years later, another robot from another manufacturer. Then how can I integrate those? So that's a problem, right? And then we also have the problem of integrating the robot with the environment, with all the other things that we have built for us, for humans, like elevators, doors, handling of different stuff. Also including integrating with other humans that are also need to operate the system. So they have to integrate everything together. So that is the problem that fleet management software tries to solve, all those things together. Then the solution that I'm going to propose is an open source one. It's been created by Open Robotics, and it's called OpenRMF. And RMF doesn't mean fleet management, as you can see, because where is the, no. So it's Robotics Middleware Framework. Yes, I know that Open Robotics never were very good with names, but that's not the important thing, okay? So we accept that. So what does provides OpenRMF? So what I want to show you is what OpenRMF is solving of those problems. And then maybe you can decide if you are going to use them. You're going to use the OpenRMF for your solution of fleet management. First of all, with OpenRMF, you can use any type of robot. Even if OpenRMF has been done by Open Robotics, that doesn't mean that your robot has to be running ROS in order to be useful in OpenRMF. You can use any type of robot as long as the robot, the manufacturer, provides a communication layer. Somehow, you have to be able to send a command to the robot, like a position, and get a status, like a battery and the location. If the manufacturer provides this, which is almost, I would say 100% of the robots, but maybe some very old ones don't, at present, all of them, then you are on business. So for using any type of robot, what you need to do is to create an adapter for your robot. And OpenRMF already provides a template. So in this image, you can see there are 3 robots, the green, the blue, and the red. And then they are all connected through an adapter which contains 3 parts. First one is the robot API server. This is the one that captures from the robot the state in terms of battery and location, and also sends requests to the robot. It says, move to this location. Then we have the fleet adapter. The fleet adapter is the part at the bottom that connects with the RMF and receives the task that has to be assigned to which robot. Then in the middle, we have the robot API, which usually it's used REST API, but you can use anything else like MQTT or direct connection or any other type of connectivity, which allows to isolate the part that is proprietary from the robot and the part that is from RMF. So that's what you would need in order to create an adapter for your robot. And this is a template that is provided by OpenRMF. So you kind of have to fill the template. What this adapter needs is to receive the robot state and needs to be able to provide the robot path request. The robot state, as I mentioned, is the location of the robot and then the battery status. Then the path request is go to a certain point. Then OpenRMF also provides a tool which is called the traffic editor that you can run with that simple command, traffic editor, and then you will get this GUI on the screen where you can have the map of the environment where your robots are going to be moving, and then you can define in green, you see, those are the lines. Those are like you can think about the highways through which the robots should move. So with fleet management, your robot cannot move freely wherever, like we are used with robot navigation. No, you have to define the paths because those paths are necessary in order to compute collisions between robots. Okay? So with this tool, you are providing to the OpenRMF system the paths that are allowed the robots to move. And the green dots, they are connection dots. There are locations where the robot can stop, can wait for others, robots to finish and to free the path. So you use this tool, which is graphical, and then you have generated all these data. In this case, in this video, you can see an example. So those in orange, this is how you see that on RBase, the visualization of the result of the paths. So this is the environment, simulated environment. We have this simple robot. And let me see, yeah. So here in orange, in RBase, you can see the path, the highways that I have defined. And then you can see in green the trajectory that OpenRMF has assigned to this robot. So that's how you see the functioning of OpenRMF and the result in the simulation or the real robot, of course. Okay, so in this case, also, I'm presenting here conflict resolution. This is something very important in fleet management. So here we have 2 robots, which are the blue and the red. And then the blue one wants to go where the red is, as you can see in the RBase. But the location is occupied, so the robot will wait there. At some point in time, the red says, okay, I want to go to another place. Then it creates the path to go to that other place, so the blue detects that and then removes itself from the position so the red can go. Now the red is going, and after the highway is cleared, then the blue says, okay, now it's my turn to go to that point. So now it goes. That position is the charger in this case, but could be any position, okay? Doesn't have to be any important. Now the blue is going, and you can see on RBase that the red one is not on the image, but on RBase, the red one has decided that needs to go to the charger again. So now it's going to appear on the image in a minute. Here it goes. But then the same problem is going to happen, that the blue is on the place. So it's going to wait there. Then when the blue is done, charging or whatever it's doing there, then it's going to decide to go to another place based on the tasks that are necessary to be accomplished. So that's a point. So now the blue wants to go to another place. You can see the green path that has written. Then the red removes from the space. The blue goes. And then it can take the position of the charger now because it's free. So that's called conflict resolution. And this is very important in fleet management. Here you can see 2 robots, but imagine if you have 50, 100 in an airport, in a warehouse, something crazy. Okay, so this has to work very well. Then OpenRMFs, it allows to assign the task to the most convenient robot. So you have, for example, this robot. We have 3 robots here, the black, the blue, and the red. Then we want to serve a coffee into a table. The 3 are free. But then only the blue and the red allow to carry a coffee. You know the holes on the top is for carrying a coffee. The other one, the black one, is for some other purposes. So OpenRMF, when you say serve a coffee to the table 7, then OpenRMF will decide which one is the best robot to work on this. It's going to be based on the battery status of the robot, on the capabilities, and on the location. So it will try to optimize this and assign and say, okay, for delivering the coffee, I think the best one is the blue. The black cannot be because it cannot serve coffee. It's for cleaning purposes. So, and also the red is too far. So that is already provided by OpenRMF. That's interesting because it's a difficult point. Then what else? We have the coordination with humans and other machines. What does it mean? It means that a robot maybe needs to go on a warehouse, go to a place where there is a robot that needs to load something on top of it. Then has to coordinate with this other armed robot that has to do this task. Or the robot takes this package and goes to the end of the room and provides to the man that has to take, the person has to take the package, and then in some way, this coordination needs to be done. How do we do that? We do that in OpenRMF with 2 concepts, which are called the dispenser and the ingester. So you create a dispenser and an ingester. The dispenser is when the robot reaches a place and somebody has to take some stuff that the robot is carrying or providing. Then what happens is that you take the package and somehow with the dispenser, you indicate to the robot that it's free. So it can continue with all the tasks or continue its path, whatever it needs to do. So that's a dispenser. You can do a dispenser that is activated, for example, by a sensor on the weight that the robot is carrying, or also in a button that is on the robot, on the screen. So when you press on the screen, then the robot knows it has been unloaded. Then the same principle is for the ingester. The ingester is just the opposite. It's when it reaches the robot a place and somebody or a machine puts something on top of the robot, and then you indicate somehow that it is. Maybe automatically detected by the robot with a sensor, or maybe the robot arm itself that says, task done. Then OpenRMF captures this signal with the ingester, and then it says, okay, now I can send my robot to the place where it has to be delivered, the load. So those are the 2 basic concepts. You can use this to coordinate with anything. OpenRMF allows you to also to control doors. In this video, I'm showing the 4 types of doors that OpenRMF is allowing to control. Here we have the RBS. We have the robot that has to cross 4 doors in a simulation. This is in a simulation. Later, I'm going to show you in a real robot. So here we have the simulation. Oh, the first door is already been opened. You can see the robot at the bottom, but you can see now the door closing behind, which is a complete door. Then the second door, type of door, is opening. Then the robot moves. After reaches the door afterwards, then it closes the door. And you can see the progress here in the RBIS. So that's how RBIS is signaling the status of OpenRMF and what the robot is doing. Okay, so here you can see the sliding complete door sliding, and then the other one, the fourth one, is the sliding but divided into two parts. So those are the 4 types of doors that you can introduce into your fleet management system, and OpenRMF already allows the control. So in order to control a real door, because those are simulated, you need to have some special hardware on your door, of course. So the robot cannot control that door just like this. So the robot is not going to be pushing the doors, it's not going to be managing the handle or else. You need to make your door able to communicate with OpenRMF. And how do you do that? Well, first you need to buy some automatic opener of the door. So this is a motor. Inside looks like this. It has a control board and it has the motor that opens. Then you need to use a Raspberry Pi and a relay. So you connect both of them. And then in the Raspberry Pi is where you introduce your connector for OpenRMF. So it's running in the Raspberry Pi. Then it signals at the moment that OpenRMF wants, then it signals the relay, which opens the door, because the relay is connected to the door in this way with the red and black cables. Then the result is something like this. So here we have our cleaner robot that is waiting for the door to be open. Then at some point in time, the door opens. Then the robot gets in. And then once it gets in, then the OpenRMF knows that and closes the door automatically behind. I have to clarify that here, the robot is not opening the door. It's not the robot, okay? It's OpenRMF. The one that is connected, you can see on the top, you can see that it has the controller that I showed you in the previous slide. Okay, so that's a typical example of controlling doors. Then the same thing needs to be done for the elevators. So if you need your robot to be traveling between different floors, you need to allow the robots to manage the elevators. And we don't do that with the robot pushing the buttons, you know? That is not practical. So many different systems, different buttons, so that's not practical. So what they do is that they integrate a system similar to the doors into the elevators, and then the elevator communicates with the OpenRMF via Wi-Fi. Like in this case, it's also via Wi-Fi. So the Raspberry Pi is connected to the Wi-Fi, and then it's inside the ROS network. Okay. Yeah, so those are 2 examples of robots that do that. In this image, I want to show you how OpenRMF can manage different levels, because each level can have a different map. So you need to be able to define the different levels and the highways on each level. So that's allowed with the traffic editor. And here you can see on the top is the level B1 and the bottom is the level B2. Let me show you on the simulation how it looks. So here is B1. We have this robot that opens the door, then passes, calls the elevator comes, and then the robot takes the elevator. All this is managed by OpenRMF. Goes down, and then gets out. So that's what the robot has done. Then what happens in RMF? So here is the B1 map. Now we change to the B2 map. So is this second area that is represented. Let me show you again. So the first one is the B1, where the robot started opening the door and calling the elevator, and the second one is where the robot just gets out of the elevator and goes to one of the corners. Okay, so that's also integrated. That's also integrated on the OpenRMF. So that's a huge job that is being done. But still, OpenRMF still can provide more. In this case, is managing several fleets. What is a fleet? A fleet is a group of robots that can do a given task. For example, we have a fleet of cleaner robots. Then the cleaner robots What they do is just to clean. Okay? But then we have another fleet of robots that is a set of robots that can deliver the coffees. So those two have different tasks by hands, then they have different areas in which they have to move and different patterns. So that's what you can see here in this image. We have one fleet of 2 robots on the image of the right. They are the providers of the coffee, and they move in the orange lines. Then there is another robot, which is the cleaner, which is at the bottom of the image. It's moving on the blue areas. So you can define all those things, and then what you can see on the image is the 3 robots moving independently. And they work in this way by OpenRMF. When a new task is taken, is received, so send the cleaner to the area of the back. Then the cleaner is going. You can see on the blue lights, there is a robot that is moving. Then serve a coffee into the table number 2. Then one of the robots, delivery coffees, moving on the orange, it's going to deliver the coffee. And what is interesting is also with different fleets, OpenRMF is managing the collisions. So you will not have collisions in this case. Because even if you are in one of the fleets or the other, it doesn't matter. OpenRMF can detect when 2 lines are going to collide, and then it's going to solve those collisions. Here you cannot see, this is real robots. Those are real robots, but I don't have the image of the reality. That's the only thing in RBase and the OpenRMF. But I think that you can get the idea. So that's an overview of what you can expect from a fleet management system. So pay attention that this is software, open source software. Still some things need to be solved and improved, but quite works very well. So if you want to learn more, you can go to the official page of OpenRMF. I have put the QR code there or the link at the bottom. And then you can see the super cool documentation they have created for this project. And then you can learn more about it. I can tell you that this is going to be, is going to explode in the next years. Most countries, they are trying to automatize all their systems. I'm talking about warehouses. I'm talking about airports. I'm talking about ports of ships. So this kind of software is going to be very, very relevant. So here you can learn more, or if you want to improve the speed of learning, of course, you can go to the construct. We have also a training, a fast training that you can take, and we'll be super happy to teach you on this. And then I think that that's all that I wanted to show you as an introduction to OpenRMF. And if you have any question, I will be very happy. Thank you. In the meantime, I put a video because it's more fun, right?
Yeah. So if anyone has any question for Ricardo, they can ask. Yeah. Can you please pass?
Yeah, hi. So the examples that you have shown were mostly for AGV. So what upgrades or additions would you need, let's say in the future, from the open source community for it to work with high-speed swarms of aerial systems? Like we have seen the drone shows that happen, but something like that, but for much more, real-life tactical purposes, search and rescue, those kind of systems. So do you think, will it evolve in future enough to be used for those kind of systems?
Okay, that's a very good point, because thank you for asking that question, because this is a common misconception in terms of the difference between a swarm of robots and a fleet of robots. That's not the same thing. Then the software, let me clarify this, okay? So the fleet is the swarm of robots is when a lot of robots, they are working, doing the same thing at the same time, right? In a group, like a show of drones. They are moving, following some patterns. This is a swarm. It's a group of robots that perform the exact same thing at the same time. Then a fleet is different. A fleet is different. It's a set of robots. Each one is going on its way. So maybe robots can serve coffee. So we have 5 robots that serve coffee, but each one is serving coffee to a different table at different times, and you don't know when. When they are not serving, they will decide to go and charge. And also there are other robots in the fleet that are doing other things, like the cleaners or the one that is loading some things on the robot. So that is the difference. So for swarms of robots, this software is not possible. You need to use another type of software, which I don't know which is. This is for fleet management. Different robots, some fleets with the same functionality, some others with don't. All together, try to make something running. Like, for example, a hospital. This project, OpenRMF, started in Singapore for the hospital of Changi. And then Open Robotics took the project and then started developing this software. In this case, the robots have to run the hospital. So there are robots that are delivering mails, others that are delivering the drugs to the patients, others are cleaning, bringing stuff. So all of them, this is the hospital as a whole entity that is managed by all different robots at the same time, organizing and coordinating themselves. But based on the requirements of the time. You know, for example, there is one room that requires to have the clean sheet. So it's now. Then OpenRMF will say, okay, one robot, go and put the sheets there. Which one? You, because you are the closest one, you have more batteries or else. And then in the meantime, the others, they are waiting, for example. I don't know. So that's the difference between swarms and fleets.
Yeah.
Very
Thank
good
you very
question.
much, Ricardo. Thank you.
Okay,
Yeah,
so
yeah.
that's it.
Okay, so moving